let's go down the list here. The announcements. Lisa will get very mad at me if I don't make her announcements. We have HP is sponsoring OpenStack Scholarship for Women. This is the URL. It'll also be posted in the Meetup page. Those of you who are women are welcome to join this. Those of you who know women are encouraged to give them this URL so they can sign up to get a scholarship, which is worth $10,000. I believe we're giving 4, or HP is giving 4 of those scholarships. The OpenStack Summit is coming on October 27th to the 30th. The next OpenStack, which is biannual, means every 6 months. And then on October 15th, our next meetup will be the good, the bad, the ugly, the truth about OpenStack APIs. Are there any other announcements that we'd like to make before I turn it over to Ahmed? Again, when you ask questions, we please ask you to speak into the microphone. This is being recorded for posterity and on Google Hangouts. And then we'll post the video live tomorrow.
Do you have the Hangout restarted, or am I starting?
I'm starting.
Yeah.
So you can monitor them. And with that, I'll turn it over to Ahmed. Thank you.
Thank you, Rick. Can you guys hear me? Am I audible?
Everybody can hear him?
No. Are you guys able to hear me? Okay, great. Hi, good evening, everyone. So glad to see. I think after a long time, I'm back here at the San Francisco Bay Area OpenStack Meetup. I think probably the last time I went, it was in Yahoo office when Sean used to be in Yahoo last year. And it's great. I still see a lot of people here, and there's a very interesting topic. I know that OpenStack has gone places now since the time we have started and we have joined this movement, and now it has it's just doing amazing stuff. All the time I see that new projects are being added, and I see that every other companies are adopting OpenStack more and more. Yeah. So on this one, I'm going to talk about how OpenStack is going to be benefit NFV platform, network functions virtualization. So before I actually start that, and before I go into the introductions and everything, I wanted to know is that how many of you are aware about the NFV as a term, or what NFV is? Because when I talk to people, say, okay, great, fantastic. Okay, but I see that majority of the people, they are not aware about the NFV. I've seen people, a lot of my colleagues and peers, they're pretty good in the virtualization, data center virtualization and cloud, but still not really much aware about the NFV stuff. Okay, so my name is Amitav. I recently moved from Singapore to here 6 months back, and I take care of the product enablement for NFV business unit in HP. And before that, I used to be part of HP Helion as an OpenStack technical marketing manager. So the current role involves me to talk about NFV, to talk about Helion Career Grade. So I'll come to some of the terms might sound very alien to you. It still sounds alien to me, like career grade, NFV, telco, CSPs, all this term that we use in NFV world, which is not very commonly used in the enterprise world, right? And so now talking about what I do. So some of my role is taking the Helion Career Grade into the conferences, technical demos, presenting to the customers, presenting to the wider audience, writing technical reference architectures, technical white papers, presenting webinars, etc. So I hope that I will try to make this particular presentation as simple as possible, because if I go deep down, so there is quite a lot of bit of CSP environment or the telecom environment deep down. So let's start with as more of an overview on this session. And if you guys are interested, and if you think that this is an area where you would like to know more, so we can do the deep dives and go further details in terms of architecture and everything. Sounds good? So in terms of when we talk about NFV, so let's talk about what is NFV, network functions virtualization, right? So if you look at there was a revolution that happened in the enterprise world in terms of the data center virtualization had come down with VMware, KVM, Zen hypervisor, etc. And then there was an era of revolution of cloud, where apps were actually moved into the web, and you access your apps through the web, and that's basically is cloud, right? And then there is another segment, which is the telco segment, the telecom companies, like large telecom companies like AT&T or Ericsson, and even Nokia, etc. So they have a huge infrastructure, which is actually much larger than those enterprise companies. Like, for example, if you look at data center or the infrastructure of an enterprise company versus telcos have like, for example, if they roll out a service like 3G, 4G, or an LTE service, so they will probably roll out like 1,000 firewalls. That's kind of the massive deployment that happens, right? And usually what happened in telco environments, so they have used their proprietary technologies, right? And now they're adopting towards the data center virtualization, or whatever we call it, the software-defined data center, or the cloud environment, right? And then they had their customer premises equipments, CPEs environment, and then proprietary equipments that they put it into the customer environment. And what happens is that the time to go to market for this kind of deployments has been very, very huge time. So, like, for example, if they want to roll out a service like 3G or 4G to a new place, so for example, a state in the US where probably LTE service is not there, and they want to start their LTE service, so they have to really, really plan long before, because the kind of devices, the kind of services, the network services they want to roll out, it's a very complex, and it's not like what you do in virtualization environment, right? So what you do is basically you just give one command or one snapshot, one script you run, 100 VMs are getting just deployed, right? So it didn't happen so far into the telco environment, right? And telco always wanted to take the advantage of this kind of infrastructure revolution that has happened, right? And thus the NFV, the revolution has come. So there is a group called the ETSI group, ETSI. So if you guys are interested, if you go to etsi.org, E as in England, T as in telco, S as in Singapore, I as in India, etsi.org. So ETSI stands for European Telecom Standards Institute, right? So what ETSI did is basically, it laid out a foundation where it says, okay, this is the reference architecture, and this is how the NFV should be deployed, and this is what is the model of NFV. So I will actually go to an NFV foundation probably in some other session. So where it says that there are different. So if you look at in a cloud environment, right? So in a cloud environment, so there you have got the physical infrastructure, the data centers, where you have server, storage, network, the hardware devices, and then on top of that you have typically an hypervisor environment, whether you use VMware, vSphere, or KVM, Zen, whatever it is, or Hyper-V, and then usually on top of that you have any cloud operating system, whether it is Microsoft Azure, OpenStack, or VMware vCloud kind of environment. And then you have other accessories like to do an orchestration automation kind of environment, where you do, like HP has an HP CSA, Cloud Service Automation, VMware has vCloud Automation Center, Cisco has Cisco ISC, etc., right? And then you have other accessory monitoring system, report logging, security, etc., right? So this entire thing becomes an entire reference architecture to have a practical cloud deployment. In NFV's case, what happens, it's a similar environment. Certain things get changed, is that the virtualized layer with the cloud that we call as a VIM, Virtual Infrastructure Manager, or NFV infrastructure layer. So when you deploy that NFV layer, or when you deploy that Vim layer, which is Virtual Infrastructure Manager, so what happens is that to get the full access, full benefits of the cloud, or to get the full benefit of the NFV environment, so it is suggested that you deploy some kind of a cloud environment, right? So whether it is a proprietary kind of cloud that you want to deploy, if you have a proprietary solution for NFV custom made, so that you can do, the best choice so far has been to adopt OpenStack, right? And thus companies like HP, Red Hat, and other companies, Mirantis, and they are trying to get this similar kind of revolution that has happened in the OpenStack for the enterprise environment. So they want to replicate the similar kind of things with an enhancement for the telco environment, to particularly to the NFV environment, right? So now, why there is an OpenStack distribution, especially for career grade, and what is this career grade is all means, right? So when we say career is basically the CSPs and a communication service provider. So any kind of services, like whether you use an LT service, or you use some kind of an CPE, customer premises equipment, or you use something like say Netflix, or over the top, we say over the top provider, or you use a voice or anything. So any kind of services, that is, whether it is audio, video, and multimedia, and communication services. So those kind of companies are called CSPs, right? And or the careers. Now, typically in a career environment, you need a 5 nines or 6 nines kind of availability, right? So you can't really, like think about a situation where you're talking to somebody and your line call gets dropped, right? So you really can't afford that. So what the CSP requires from the NFV platform? So what is the expectation for the CSPs? So when I talk about CSP, so it's easy to think about it as a telco, any telco company, right? So what a typical telco or a CSP will actually look for from the NFV platform. So the first thing they will look for availability and reliability. As I said, if the call gets dropped, so you really can't, your service has to be really, really highly available, right? Even a second of drop or second of failure for that particular service is not going to be acceptable, right? Reliability, it has to be highly reliable. The underlying infrastructure that you deploy, that has to be really, really highly reliable, right? And it should have an advanced self-healing, right? For example, if there's a service, a particular service is running, and there is an infrastructure below, and then there is some kind of issues on the infrastructure, and it should detect automatically, and it should do a self-healing before there any kind of outage happens, right? No single point of failure. So that's something that the CSPs can't really afford. Performance, near line rate networking throughput. So this line rate is typically an telecom term, which I also didn't understand initially. So when I say line rate, is basically what you get on the physical wire, the kind of bandwidth that you get on the physical wire.
Just ignore me.
Sure.
It stops sharing your screen for some reason.
Really?
Yeah, see if I can figure out. Keep talking.
Okay. So when you talk about the near line rate networking throughput, so it talks about whatever you get onto the physical networking network infrastructure, the similar kind of network bandwidth and similar kind of performance that you get onto the virtualized environment as well.
So your screen share.
Okay. Then it says the bare metal compute performance. So you might have seen, and as you are aware, that when you implement virtualization with any kind of virtualization as best is possible, but still, there is somewhere there is an overhead, right? And but in a CSP environment, this overhead we really can't afford to take. Can you see that?
Working. I might have to take you out of full screen mode.
Sure.
You're on this one.
This one.
What's that one?
Whatever. Yeah. This one.
But this isn't changing. So they're just seeing that.
Okay. That should.
Can you just
Yeah.
yes, just do this.
Okay. So yeah, bare metal compute performance. So the kind of performance that you get as you would get in a physical, say, HPDL, 380GH server, something like this. Manageability, in-service upgrade capabilities. So if the new version of the software comes, it should be easily upgradable. Enhanced security. The security is one of the, right from your host operating system to the top layer, the security has to be absolutely tight because you are dealing with a massive amount of users. Fine, okay. Advanced resource scheduling and orchestration capabilities. So the resource scheduling in terms of, so what typically you actually run on NFV environment is not your apps. So when you look at a cloud environment, you actually run the apps, right? You will probably virtualize your application, or you will write an application which is made for cloud, and you will typically provision that, and you will let your users access that, right? But in a CSP environment or in an NFV environment, what you actually use is called VNFs, virtual network functions. So to make it easier, VNFs, let me just ask, how many of you are actually aware about the VNFs, or how many of you hear about? Okay, so VNFs are basically virtual network functions. One of the easiest example I could probably give is, like, for example, F5 big IP virtual appliance that you might have seen, or the virtual load balancers kind of environment. So typically a load balancer can be, or Citrix NetScaler is, I think, probably an example, right? So Citrix NetScaler or any kind of load balancer, which used to be actually hardware devices, right? And then all these vendors, they thought that deploying this kind of devices and there's like provisioning, deprovisioning, this kind of devices had been really difficult job, right? And so they came up with an idea that this should be virtualized so that it's an easier access. And think about a situation where to deploy 100 appliances, physical appliances, it takes a lot of time, a lot of other bottlenecks as well. But wherever, if I virtualize it, and probably within an hour, I can actually deploy 1,000 virtual appliances so easily, right? So the VNFs are, yes. So I would say VNF is something like a combination of services, a combination of VMs, which runs a particular network function, right? For example, if there are companies like McAfee, there are companies like Palo Alto Networks, etc. They are prominent VNF makers. So what they do is basically on the network environment or the CSP environment, there's a particular function that they want to run, right? For example, say there is a packet inspection operation that needs to be going, right? So that's a particular application, but that may need probably say 5 VMs. So there's entire 5 VMs, with that entire software stack comprises makes one VNF, and that VNF runs on top of a carrier grade OpenStack operating system. Just give me 1 second, sorry. Oh, I can't. Okay, so why OpenStack? So if you look at the CSP environment, the telcos, so they mostly prefer 97% of service providers, they consider open source solutions, right from the CTO and the CXO levels. The benefits of open source, we know it. We all are here for the OpenStack and OpenStack Meetup, and we know that how OpenStack has grown up, how Linux has changed the world. And first, specifically for telco environment, what really makes a difference is that the kind of massive infrastructure they grow into. And if they get into a logged environment or a proprietary solution, so to come out of that particular thing can be really difficult. And another thing, what happens is that whenever there's VNF makers like say Palo Alto Networks or McAfee or like that, whenever they make those applications VNFs, whenever they make it on an open source environment, so that becomes an universal access for other CSPs as well. So one CSP having a log solution may be tied to just one particular vendor. So this you can see the open source software, how it has grown, all the words right from WordPress, PHP to Linux, compared to Windows, and then there is Apache, etc. And I think this is we all know about it, so I'll not go much deep into this. So this is something I think probably you guys have seen this slide. What is HP's contribution into the OpenStack, and why we came up with a career grade OpenStack distribution, very exclusive, which is not meant for, typically not meant for enterprise. It is the performance and availability and reliability wise and the manageability wise much higher than the enterprise OpenStack. So this is the Helion OpenStack career grade. So when I say the Helion OpenStack career grade, or we call it, we have given a short name, it's called HCG, Helion career grade. So when we talk about HCG, it's basically another distribution from Helion portfolio. So if you look at HP's portfolio, so we have HP Helion OpenStack, which is basically the enterprise edition meant for the private cloud environment. Then there is HP Helion Cloud System, which can be implemented on a converged environment kind of thing. And then there is Helion OpenStack career grade. So the career grade is specifically meant for the telco environment. And yeah, so here you can see how the career grade features have been incorporated onto this. So we'll go a little deeper into this later on. So to achieve this career grade features, so what HP did is that we have did a partnership with Wind River. So if you look at HP's background, so we have been number one contributor onto the OpenStack in terms of code contribution, and then there is Wind River. So they are the number one for career grade Linux. So they have an excellent career grade Linux. So if you really want to know about what is career grade Linux, so you should go to Linux Foundation, and there's a revision number, I think right now it's 5. So you can see what are the features that should be career grade Linux. What is the difference between a career grade Linux and an usual Linux, that enterprise Linux that you use. I'm not able to see that. Okay. So so career grade functional components, HCG functional components. What are the different functional components? So you see on the bottom, you see on the yellow color bar, it's a standard server platform, or we call it COTS kind of environment, which is the basically standard hardware, whether it's HP, IBM, Dell. Kind of hardware, whether it is server, storage, and networking. And on top of that, we have, you see that there are violet color boxes, which is one is an AVS, OVP, then there's a blue color box, which is called career grade Linux. And on the left-hand side, there is career grade management and middleware. So what we did is basically we created 2 regions for a best performance and a best manageability situation. So the right-hand side denotes the kind of environment which will take care of the absolute career grade kind of features in terms of the vSwitching, virtual switch, and then in terms of KVM hypervisor, which has been tweaked and made as a career grade. So I'll come a little bit details into this, and then there is a career grade Linux, right? So if we pick up a distribution of Linux, so that's whether it is Canonical or Red Hat or any other Linux distribution, that's not a career grade Linux. Those are usual. You can probably at best can talk about that's an enterprise Linux, but it really doesn't meet the CSP environment needs, like the reliability, the kind of high availability, and the security requirements that the career grid talks about in the revision 5. Right. So, and if you look at this, there are special VNICs are there, Intel DPDK support, data plane development kit. So what DPDK does is basically it does a very, very fast packet processing. So in a typical CSP environment, the kind of applications that run, the VNFs that run, so they need a higher throughput, higher bandwidth, and the packet, the network packet should be processed very, very fast than usual applications in the enterprise environment. And then on the left-hand side, we have the career grade management and middleware. We have the VM high availability management things, and we have performance management, fault management. We have Helion lifecycle management to take care of the entire lifecycle operation, right from installation, provisioning, deployment of the OpenStack distribution. All right, and on top of that, you see the green colors. Those are actually the VNFs. So you can think of the VNFs as the apps in the enterprise environment, right? So and you see that there is an accelerated virtual port or AVP VNIC driver. So you see the 3 boxes. There are top 3 boxes are on the where it is written that AVP. So those are basically 3 VMs, the guest VMs that are running. So in an enterprise environment, so you run the guest VMs, right? And on top of that, you run the apps. So here on the guest VMs, you actually run the VNFs, the virtual network function applications. Right. So these guest VMs, when they are equipped with a special AVP driver, so they give you a very, very high throughput. Right. So we'll come into then the entire statistics, how it gives it different throughput and what are the difference than usual OVS environment and AVS accelerated vSwitch. Sure.
What is the standard server platform? Is it all Intel only, or do you support other?
Okay, that's a good question.
What was the question?
The question is, what is the standard server platform? Is it an Intel only, or is it a non-Intel as well? Okay, so far it has been Intel, because the majority has been Intel. So whatever the non-Intel environment it had been, so I think the industry itself is discarding, right? So I think, yeah. So, but yeah, but NFV, in a way, it really doesn't talk about whether it is just Intel. NFV doesn't talk about whether it just, but it says a standard x86 architecture.
Can you explain a little bit more about what you mean by carrier grade Linux?
Oh, yeah, sure. I'm coming to that particular slide.
Okay.
So you talked about career grade features or the career grade Linux?
Just what you mean by that term.
The career grade Linux?
Right.
Okay. So when you talk about the career grade Linux, it has to conform into the specifications by Linux Foundation. The Linux Foundation has released the revision 5 of the career grade features, where there are different security requirements. There are requirements in terms of what kind of throughput it gives, what kind of reliability, and what kind of availability it gives that.
Is there testing involved to verify that meets those standards?
I believe there's a consortium. So if you go to Linux Foundation website, so there is a particular specification, you have to submit some paper or something. I don't know exactly the procedure, but that's how it goes through. There's a consortium, of course. Yeah.
Thank you.
And I remember there are a lot of companies are part of that. Oracle is part of that. Intel is part of that, and there are a lot of other companies part of that. So this kind of performance that is expected from a career grade. So usually you will see that the kind of latency and the jitter that you see if you look at the red environment, so non-carrier grade environment, you will see the jitter and the latency, it's going through, going all of the places, to up to till 50 microseconds. But wherever we have implemented this carrier grade feature, and you see the jitter comes down and the latency comes down to max at 10 level. So here we talk about the accelerated carrier grade data plane. So here we talk about what kind of networking enhancement that we have done. So here you see that we aim at 20 gig line rate performance. So 20 gig of throughput into the network environment performance, just on 2 cores. So if you look at now the standard OpenStack into the enterprise environment, so you basically on a 2-core CPU or from a 2-core of a CPU, you actually can't get anything out there, right? But and the kind of environment, the kind of throughput that we require for an CSP environment is a 20 gig, right? So to get a 20 gig environment, if I have to implement in a standard OpenStack environment, and the kind of CPUs that I will need, it will be actually huge, right? And that's where your carrier grade Linux and the carrier grade OpenStack and the carrier grade switching and the carrier grade KVM comes into the place. So you see that there is an AVS. So when we say AVS is an accelerated virtual switch. So what we do is that we have not taken this OVS, Open vSwitch, that is prevalent in the OpenStack. So we have taken this accelerated vSwitch, and which gives us this kind of performance, 20 gig line rate performance on just 2 cores. And so what happens? It sits on a it sits on a top of a typical standard host, which has a carrier grade Linux and a carrier grade KVM. The carrier grade KVM is called OVP, Open Virtualization Profile, and then there is it sits on a standard x86. This gentleman asked me this question. So standard Intel x86 server. Right, and then there are OpenStack plugins are there, so Neutron, and then there will be ML2, ML3 plugins are there, and it connects to different SDN solutions. Like in case of here, so we connect to HP's DCN, Distributed Cloud Networking SDN solution, and for a multi-center environment. Right, so what happens is that, so when you want to achieve the higher performance, so there is a DPDK driver that you implement on each VM. So you have a DPDK, and then there is a special VLIC that you use instead of the word IO. So that is called AVP. So AVP VLIC will give you that kind of throughput. So you see the throughput on the guest throughput on the right-hand side bottom.
So can I ask you a question about
Sure.
the OpenStack plugin? So are you supporting ML2?
Yeah.
So you have your own OBS device driver that's different than OBS?
We don't use OBS. Yeah, we don't use OBS here. We use the AVS here. The switch.
So you have an ABS mechanism?
Correct. The switch itself gets replaced here. So if you look at the Helion carrier grade Helion OpenStack, which is the enterprise environment, so that uses OBS. But if you look at the Helion carrier grade OpenStack, which is for the CSP environment, so the entire vSwitch gets replaced. So that's the AVS part, and that's how the entire throughput is coming through AVS, because OBS at this point of time cannot achieve this kind of performance. So you see, AVS has been optimized for Intel DPDK kind of environment. So Intel DPDK, I know that there are some work is going on the DPDK on the OpenStack front as well.
So is AVS proprietary or is it?
AVS is proprietary at this point of time, but we are closely monitoring the OBS as well, the kind of development that's happening on the OBS, and we are. I mean, by nature, HP has a culture to do whatever they do is going to the upstream. But because AVS is not a project within OpenStack, so we can't contribute at this point of time. but at the same time, to meet the business requirements for the CSPs, we need something which the OVS cannot meet at this point of time. Does it answer your question? Okay. It supports the WordWire for VNFs as well, for OVS and the native Linux. The usual Linux will have the WordIO driver, so it will support that as well. Plus the AVP driver as well, if you want to get an Intel DPDK based higher performance. So this is an interesting graph. So this is an interesting graph. You see the configuration assumptions. We have taken 24 cores and per VM, per core 1 VM, and we wanted to achieve 2 Mbps, 2 million per second bandwidth. So if you look at it, there is a comparison between the standard OVS and the Helium carrier grade ABS accelerated base switch. So in CG ABS or carrier grade, we just need only 4 cores, and we can achieve this one, 2 Mbps thing. Whether if I want to do the similar thing with the standard OVS in OpenStack, I need 20 CPU cores. So think about if I want to, think about in an environment for an NFV where I want to go as a larger scale deployment. So what kind of CPU I will require? How many servers that I will require, right? And so number of cores available for the VMs, you see that there are just in the standard OpenStack only three are left for the VMs, whereas I have plenty of cores are available in carrier grade AVS, right? And the kind of VM density improvement, it's almost 7. You can see that 3 to 20 or 21, so almost 7. So 7 times that you get the VM density. So for example, with one particular server, if I can have 3 VMs on a standard OpenStack environment, in a carrier grade, I can have 21 VMs.
Question, Helium is internal HP product.
So Helium is the branding that we have given to the HP cloud actually. So I would say Helium equal to HP cloud. So that's the right way to understand. But yeah, under HP Helium, so there are products and services, and even the trainings as well, and the consulting services as well. So which brings up the entire platform.
I'm asking the question for the accelerated Open vSwitch
Mm-hmm.
that you talked about.
Mm-hmm.
Where does that come from? Is that developed here, or do you partner with someone?
We have partnered with Wind River. So those special kind of carrier grade features that we have partnered with them, and we have integrated. So we have a joint R&D that we do. So carrier grade hardening. So what kind of hardening that we expect in a carrier grade environment, which is a little unlikely into the standard OpenStack environment. So it has to be an automated installation, definitely. Dual redundant control node architecture, automatic control node failure detection. So failure detection recovery, which is absolutely necessary for a carrier grade environment, because there can be no downtime, or very, very less downtime. So, and automatic compute node failure detection recovery, carrier grade VM VNF client APIs. So why these APIs are required? Because you need a higher throughput, you need a faster packet processing, etc. Automatic VNF failure detection and recovery. So if there is a VNF is failing, so that should be automatically detected, and the corrective measures should be taken. Orchestration hardening. So this is a very interesting thing, because all of you know that the OpenStack heat we have been using for more than a year now. I think it's 2 years now. But there were a lot of bugs on the heat, and then whenever we wanted to use that heat orchestration for carrier grade features, we couldn't do that because it's basically not optimally perform, right? So we had to take this heat project and specifically make some amendments to make it a career grade ready. Then standard OSS, BSS operation and the business services, fault performance management, data aggregation feeds, intelligent VM launch support, Nova scheduler service that we have done some improvements. And this is meeting the CSP requirements. So what actually a CSP or a telco looks from an OpenStack or from an NFV kind of environment. So it wants the detection, the failed VM detection should be 500 millisecond or so. 500 millisecond or so. Whereas in a standard OpenStack and an enterprise Linux, if you use a standard OpenStack and a standard Linux, you will see it's more than 1 minute if there's a VM failure is there, right? Whereas in an Helium career grade, it is a 500 millisecond, right? And compute node failure detection, it's a sub-second, whereas in case of a standard OpenStack and a standard Linux, it's a 1 minute or longer. Control node failure recovery, so if there's any of the OpenStack services, the standard services got failure, and the entire recovery takes, there's no time actually specified for standard OpenStack. So but here we can't afford to go than 10 seconds or more.
So
yes.
What do you do after you detect certain nodes fail? Are failing.
Oh, so we haven't the detection failure built into this environment. So if you're interested, I can actually after this I can show you the entire architecture. So yeah, there is a self-healing into this particular one built into the HCG.
That really depends on use case and workload, because it really depends on whether it's the failing node is stateless or stateful. How do you deal those kind of distinguish those kind of different kind of situations?
Okay, I can talk about that. I can show you some of the slides there, that particular thing. So then there's the live migrate DPDK apps. So usually the apps on a KVM and the standard KVM environment, you can't do a live migration that you can do in a VMware vSphere kind of environment. But whereas the way we have taken KVM here is that we have modified the KVM and made it as an CSP environment where you can actually live migrate something like the features that you have enjoyed in vSphere, right? So and if your app or the VNF is DPDK enabled, right? So and then there is a network failure detection for compute nodes. It's usually 50 seconds, and in a standard OpenStack environment depends on what Linux distribution that you are using. So this is the feature that I was talking about. So there were some bugs on the heat environment. We have taken this heat and we have made some changes to make it CSP ready. And so we changed the templates, the entire to support lifecycle commands, and then there is an advanced heat services. So this supports this SNMP and REST-based APIs as well. So these are the fault management features that we have introduced, the SNMPs and HTTP to GUI and REST APIs.
One more question.
Sure.
So when you say how fast you can detect the failing nodes in a cluster, what is the context in terms of the size of the cluster? Typically, when you're reporting those, how fast? Yeah. Can you give me a rough?
Okay. So the size of the cluster for the compute nodes, when we started Helium career grade, the first version was 1.1. The current version is 1.1. So we could not scale because of some of the design constraints, which was, I think, 11 nodes that we have started with.
11 nodes?
Yes. But the good news is that the HCG 2.0 is coming out, which is in December, and that has a 50 nodes guaranteed, and then it can go up to 100. I should not be committing this one right now because it's on the product roadmap, but yes, that's something. So there are some VM scheduling enhancement also, like NUMA node awareness, CPU spinning, etc.
Is there anybody using that? Like, are you pulling that out from what Intel's doing?
Oh, yes. So you might have seen the big news with Telefonica. Telefonica is the third largest CSP in the world. So we have signed a deal with Telefonica, and there's recently one deal signed. Unfortunately, I can't disclose the name at this point of time. There's one major operator that they have signed for HCG. And then HCG is also, like for example, if you looked at HP Helium cloud system, right? So the cloud system comes as an, like Helium comes as a base operating system, right? So we have something called NFV systems. So which is NFV system is basically you get in a box, like a rack, where you have the compute, storage, and networking, and the softwares are inbuilt. So the software, the NFV I software or the cloud operating system software is the HCG, Helium carrier grade. So that comes as an entire box kind of environment.
Are you talking about a NUMA-based cluster that?
No, that's not a NUMA-based cluster. That's a standard. But when you implement this, you can implement the NUMA environment here in the HCG.
How do you ensure SLA and true fluence? SLA and true
Uh-huh.
How do you ensure? How do you make OpenStack ensure certain level of SLA and fluence? Service level agreement.
The service level agreement?
They don't have any requirement.
Well, yeah. So the service level agreements are, so that depends on what kind of the CSP environment, what the CSP requires. So if you looked at the slide here, so this is the CSP requirement, right? And this is what we meet at this point of time. So if you look at the first column, which says HP Helium OpenStack carrier grade. So this is what our engineering has produced.
Okay, back to the side of classic.
Yeah.
Yeah, I understand.
Yeah, every product goes through a phase, right? I mean, it's the entire NFV itself is pretty new, right? I mean, you wouldn't see too many players here. Sure.
You're giving some really good ideas. One question I have is when you are showing those performance numbers, running on lesser number of cores and much better performance numbers. So you have multiple VMs running simultaneously.
Right.
You get asked about performance isolation. Meaning, what if, because when you are doing, mission critical applications such as, those you're describing, carrier environment, do you get those questions? Those type of questions, meaning if one VM takes up more of the resources, how do you ensure that other VMs also have a fair share of the memory and all that?
Well, honestly speaking, I'll not be able to give you the right answer at this point of time, but I can get back to you on this. Thank you.
This is like nothing to do with
Yeah, good question. I actually keep asking this question to my product management team and the R&D team. So
they don't have any such requirement.
Bare metal is there. Yes, absolutely. So when we first started this project, we wanted to include bare metal. But if you look at HP Helion OpenStack in the Enterprise Edition, we have done a lot of work. I think we are probably the number one who actually pushed the Ironic project. And now Ironic, I think, is part of OpenStack. So the bare metal provisioning was one of the things that our customers always requested. And we knew how it was important, the bare metal, especially for enterprise environment where they have a traditional app sitting like Oracle kind of apps which are already sitting on a bare metal environment, right? So not that every app that you can virtualize, right? Yeah, so that is there in the enterprise OpenStack environment, and we want to do the similar kind of thing on the bare metal provisioning here, because some of the VNFs are not yet virtualized. Those are still there on the bare metal. They run on VNF, though less it is, and going forward it will be much lesser. But yes, they are still there. And we wanted to incorporate on the first version. We couldn't do because there were time challenges were there because we had to deliver the product and etc. In the next version, we are coming up with a bare metal provisioning thing, full-fledged bare metal. We will see, and there are a lot many other things. Unfortunately, I can't talk about it because it's something that are on the product roadmap. But yes, that is there.
So are you focusing on hyper-convergence or hyperscale or both? Or you're not focusing?
We are not actually focusing on none of them. I mean, any of them, yes, yeah. We are not. We are specifically focusing on career grade. So that's why in all our presentations, in all our talks, you will see career grade, right? If you go to any OpenStack talk or anything, they will never utter these words, two words, career grade, right? Whereas NFV, the moment you come to NFV, one of the very frequent, hard words are career grade.
One is how large is the cluster, the size of cluster is. The other is how fat or how heavy the one single. That's how.
No, but I can. Okay, so this is a very realistic thing that I can tell you because why I can tell you this. So part of my role also involves to look at the research, what market is doing, or where this NFV direction is going on. And I can tell you what the current the state of our Helion career grade is. It's probably by far the best career grade operating system that you can find in the market at this point of time. It's a true career grade. It's not a marketing statement, but I can tell you the kind of development that has happened in the NFV segment. Yes, it is at this point of time. And the entire HP NFV architecture. So if you go to the Google and just type HP NFV, OpenNFV architecture, so you will see the way HP has designed the NFV architecture that conforms absolutely to the HC standard, the complete, less dependence on the partners. We have more than 200 partners connected to us, but most of the components are actually ours. So your support and reliability comes from one single vendor company, right? Okay, and coming to your question, why the containers? I actually asked this question because there's a lot of movement is happening on the containers, especially on the OpenStack. VMware has adopted containers. Microsoft has now gone with open containers as well. So containers, I think, will take little time. It's my personal statement. That's not an official statement. Container will take little time to come into the NFV environment because the kind of application that NFV runs, like we call it a monster VM, right? So it's like big, fat VM kind of environment. And the containers are like lightweight kind of application that you run. Yes.
In terms of networking differently for container, that's the hardest part.
Yes.
Yeah.
And this is a network centric, right?
It's upside because it's much less open.
Right.
But for networking, a lot of work because there's so many more IP address, right?
Absolutely.
Think about it.
Absolutely. Absolutely. And NFV is like, if I compare NFV with a standard enterprise OpenStack environment or thing, so standard OpenStack environment is an app-centric, right? So what you do is basically you deploy OpenStack or cloud just to access your apps through web, right? That's the fundamental. See, if I say what is the definition of cloud is accessing your app over the web. That is basically, then you come, all this, the virtualization, that orchestration, automation, this all comes, right? But basically, fundamentally, it is that you access your application over the web, and that is cloud in a very simplified statement, right? But whereas in an NFV environment, it's the VNFs that matters. It's not the apps. So when you talk about the VNFs, it's the virtual network functions. So a particular telco runs the virtual network functions, which are a complicated network function. So which could be a combination of multiple network functions, spanning over multiple VMs and with a complex network architecture. And that is where the difference between a standard cloud environment and a NFV environment, because the networking is complex. Your SDN, the V switching that you're using. So those things have to be really, really, really the best. Okay, great, thank you. And is there any other question that I can answer? Sure. Yes, of course. I will upload the slides, and I'll make sure that every one of you get access to this particular slides.
It has a bunch of
I will come.
concepts.
Sorry, what is that?
Proof of concept.
Yes.
Are those available to everyone or only?
Yeah, so so this gentleman asked a very interesting question, whether there is the proof of concepts, the POCs, whether they're available for public. So if you go to HC's website, etsi.org, so there's a lot of reading materials are there. The PDFs are there. And you can see that how deployment architectures are, how the proof of concept should be, what kind of environment, how the network should be, how the Vim layer, which I talked about, virtual infrastructure manager layer. You can't?
No, it says you have to be a member.
Oh, you have to be a member of HC? Okay. Okay. But a lot of stuff says, especially the PDFs are actually commonly available. You can go ahead and download those. That's not. HC itself is HC is open.
Do you see any sort of InfiniBand adoption among your customer?
Sorry, was it?
Telecom InfiniBand.
In
InfiniBand is sort of a very high speed switch.
InfiniBand.
Yeah, InfiniBand, yes.
Okay,
There are quite a few companies they're working on InfiniBand. It's a very high speed networking for data center.
Oh, I should talk to you.
There's a public company. It's called Melonix. M-E. Yeah, Melonix. They're one public. InfiniBand.
How do we get the slides?
The slides will be Rick will be uploading the slides onto the Meetup site.
There'll be a link in the meetup. Okay.
I think that's the procedure.
Okay.
I used to run the Singapore OpenStack Meetup.
Okay.
And
Could you put up the one that you had just a couple of back, the one that said performance?
Oh yes, absolutely.
The VM performance. Just put it up right here.
All right.